So let's talk about the atom and atomic structure. An atom is the smallest identifiable unit of an element. So as we talk about an atom, we're going to talk about what actually makes up an atom and how did the atom come to be. So when we talk about an atom, it's really important to know that atoms are really, really small, as well as what makes up an atom. We're going to talk about the nucleus and different parts of the atom that are inside and outside of the nucleus. So when we talk about an atom, first remember that Democritus suggested that if we divided matter, we would end up with these tiny, indestructible particles called atoms. Now, 2,000 years later, John Dalton formalized an atomic theory. So that's Dalton's atomic theory, where he gave three postulates. Now, in terms of the atom, we're going to really focus on the structure of the atom itself. So if we think about an atom as the size of a football field, now we know that atoms are really, really small, so they're not the size of a football field, but we're just going to compare the size of the atom to the nucleus. So imagine that an atom is a football field. The nucleus is a marble that we put right on the 50-yard line. That gives us this idea for how tiny a nucleus really is within an atom, because we know atoms themselves are tiny, tiny, tiny particles. So this just kind of gives us the relative size of an atom. Now, in terms of what makes up an atom, we have what are called subatomic particles. So subatomic means that we have smaller particles within the atom. And we have three main subatomic particles that we're going to focus on. We have the proton, the neutron, and the electron. So even Dalton thought that there were only atoms, that there was nothing else. And then J.J. Thomson discovered an even smaller particle called the electron, and Ernest Rutherford discovered the proton and therefore the nucleus, this positively charged center of the atom. Now, let's talk about each one of these subatomic particles. So the proton is the same as the atomic number. This atomic number is on the periodic table. We're going to look on the next slide about what the periodic table shows us. But the number of protons are called the atomic number. This is what defines an element. So every element has its own atomic number. Helium's atomic number is 2, therefore it has 2 protons. Carbon's atomic number is 6, so it has 6 protons. Now the proton is located inside the nucleus, and the proton is positive. So every proton has an electrical charge of +1, and the proton is located inside the nucleus. The other subatomic particle that is inside the nucleus is the neutron. Now think about that word, neutron. It is neutral. So within the nucleus, we have these positively charged protons and these neutral neutrons. And we're going to talk about why the nucleus is what makes up a majority of the mass of the atom. Now, outside of the nucleus, we have what are called electrons. And this is what J.J. Thomson discovered using his cathode ray tube experiment. And what he found is that the electrons have a negative charge. So we have the proton and the electron, which are equal in magnitude, so +1 and -1, but they're opposite in sign. And so when these two particles are paired together, they cancel out because +1, -1 is 0. Now, protons and electrons, if it is a neutral atom, are equal, right? If it's a neutral atom, the protons and the electrons are equal. So if there are 5 protons, there must be 5 electrons to keep that neutral, to keep the charge 0. Within the nucleus, so we notice here the proton and the neutron are inside the nucleus. And so the nucleus is what actually makes up most of the mass of an atom. Even though the nucleus is so small in relation to the atom, that's where most of the mass is. So mass number is actually the number of protons plus the number of neutrons. So most of the mass exists in the nucleus. This mass number is a whole number. So it is 4 plus 7, right? It'd be 11. 5 plus 12, right? 17. Mass number is a whole number. Average atomic mass, this is what's found on the periodic table. And there is a difference between the two. When we talk about isotopes, we will talk about average atomic mass and the difference between mass number and average atomic mass. So just a quick summary, kind of what was on the slide before. Atomic number is the number of protons in the nucleus. Now, atomic number is represented by a capital Z. So the symbol for atomic number is Z. Again, the number of protons in the nucleus. Atoms of the same element will always have the same number of protons. If you change the number of protons, you change the element. So if you go from 6 protons to 7 protons, now it's no longer carbon, it's nitrogen. And if you say, how did you know that? Look on the periodic table. The atomic number is given to you on the periodic table. Mass number is represented by a capital A. Right? And I know these don't necessarily make sense, but mass number is represented by a capital A. This is number of protons plus number of neutrons. So mass number is number of protons plus number of neutrons. And so then to determine the number of neutrons, we do mass number minus number of protons, just manipulating this equation. In a neutral atom, the number of protons equals the number of electrons, positive 1, negative 1. So what information does the periodic table give us? On your periodic table, you have this actually at the top. It gives us the element name. The number right at the top is the atomic number, which is the number of protons. It gives us the symbol, the average atomic mass, and we won't worry about electronegativity for now. And so this is what you have on the periodic table, but we will also see what is called isotope notation. And isotope notation looks like this, where we have a number on the top, a number on the bottom, and the symbol. The number on the top represents the mass number. That is the number of protons plus number of neutrons. The number on top is going to be the larger number. That's the mass number. The number on the bottom is the atomic number. That is your number of protons. And then you have the symbol. So over here, notice we have a mass number of 14. Protons plus neutrons. Bottom number is the atomic number. That's the number of protons. So from this, you can figure out the number of neutrons. 14 minus 6 gives you the number of neutrons. Because remember, mass number is protons plus neutrons. This is number of protons. Now, we will talk more about isotopes and what they are. But isotopes, for now, all we need to know is that they are the same atom. So notice these are both carbon. They have the same atomic number. Otherwise, you change the atom itself. And then the only difference is that they have different mass numbers, which means they have different number of neutrons. Now, when you write the name, this would be carbon 12. So you write the name with the mass number at the end. So here's your mass number. This is carbon 14 because the mass number is 14. So this is a general overview of atomic structure, number of protons, neutrons, electrons, how do we find mass number, isotope notation. We will talk more about isotopes and average atomic mass later.